Hello everyone. Today we're going to look at the mean, which is also called the expected value, and the standard deviation of discrete random variables. The expected value is what you would expect to get in the long run. And again, this is just another word that means the mean. So the expected value is sometimes denoted by e of x. Remember, x is the random variable. But it's also equal to mu, which again is the symbol we use for mean. And it is the sum of the values x times the probability that x equals x. So we're going to find the expected value for x, which is going to be the number of heads in 3 coin tosses. We need the table of values, which we looked at before. So if x is 0, then p of x equals x is 0.125. The probability of 1 head is 0.375. The probability of 2 heads is also 0.375. And the probability of 3 heads is 0.125. So mu, or again, e of x, is the sum of the products of the value times the probability. So 0 times 0.125 plus 1 times 0.375 plus blah, blah, blah. If we add them up, we get 1.5. This means that we would expect 1.5 heads out of 3 coin tosses. So again, if I kept doing this over and over again, I kept flipping the coin 3 times, recording how many heads it was, you would expect most of them to be around 1.5 heads. Now we know that it can't actually be 1.5 heads, but hopefully that makes sense. There are 3 coin tosses. It's either a heads or a tails. The probabilities should be equal, so you should get half of them being heads, half of them being tails, and half of 3 is 1.5. So let's try another one. So we'll find the mean for the following distribution table. So we don't know what they represent, we don't know what it stands for, but it doesn't matter. I have the values and I have their corresponding probabilities. So e of x, which again is the same thing as mu, I'm going to just add the products of the values and their probability. So 0 times 0.15 plus 2 times 0.5 plus 2 times 0.2 plus 3 times 0.15. And I get 1.35. Now again, remember, the expected value is another word for mean. The mean is a measure of center, of the middle. So hopefully it makes sense that this number here is somewhere in the middle of these guys. Okay, so you should always go and make sure that it makes sense. If I ended up with 5, I would realize that can't possibly be true because x doesn't even go to 5. So how could I expect x to be 5 if it's not even a possibility? Right, so always make sure that it makes sense. The other thing we're going to look at is standard deviation. So sigma, again, the symbol for standard deviation, is the following. There are 2 different formulas for it. You can use either one, whichever one you prefer. In one of them, the first one, we have that we're going to multiply the difference between the values and the mean, square them, and then multiply that by the probabilities. Add those all together and then take the square root. This is very similar to finding sigma of a data set. And then the other one over here is just taking the value squared times the probabilities and then adding all those together and then subtracting mu squared and then square rooting. In either case, we need to know mu. It pops up in both of them. So we need to make sure that we know what mu is when we do the formulas. So for example, we're going to find sigma for the number of heads in 3 coin tosses. And for our first example, we're going to use the first variation of the formula. So I will take the difference between our value and the mean. Remember, the mean was 1.5. So here is 0 minus 1.5. Here is 1 minus 1.5, 2 minus 2.5, and then 3, 1.5, and then 3 minus 1.5. So the values minus the means, we're square them and then multiply by the probabilities. Once we do that, we get the square root of 0.75, which is roughly 0.866. And we'll do another one. So find sigma for the distribution table from before, which again I've recreated here for you. And in this case, we're going to use the second variation. So the second variation, remember, is the value squared times the probability. We're going to add all those up, and then at the end, we're going to subtract mu squared. So mu was 1.35, so that minus 1.35 squared is minus mu squared. If I do that, I get the square root of 0.8275, which is roughly 0.9097. Okay, so this is all calculator work or Excel work. You can plug that into Excel too. And we'll do one more example. So find mu and sigma for the following distribution table. So again, we've got the x values, we've got the probability that x is x, so we have all the information we need. Since we need mu to find sigma, we're going to find mu first. And again, that is just taking the product of the values and their probabilities and then adding them all up. If I do that, I get 5.3. And then to find sigma, again, I can use either of those two formulas. In this case, I'm going to use the second formula. So it's the square root of the sum of the products of, again, our values squared times our probabilities. And then we're subtracting mu squared. We get the square root of 3.71, which is roughly 1.926. Okay, so we have some fairly nice formulas. Depending on how many different values x can take, it can get a little long. But don't forget that you can use Excel to create really nice tables, and you can just plug it into the calculator, and it really shouldn't be too hard. So read through the book, try some of the homework, and let me know if you have any questions. Good luck.